dimensional consistency of equations in physics. In physics, every equation is dimensionally constant. Like what I mean to say, for example, V is equal to U plus AT is the basic equation we know. See, the dimensional formula of V is L power 1 T power minus 1. Here is equal to there means the dimensional formula of U also L power 1 T power minus 1. Yes. And even AT together also will give you L power 1 T power minus 1. This is the meaning of this. In the entire physics, like wherever E is equal there, or you are doing addition, or you are doing subtractions, only we will do these when they are dimensionally equal. When they are dimensionally equal, like any formula you take it, like V square minus U square is equal to 2AS, means the dimensions of V square, dimensional formula of U square, dimensional formula of 2AS must be equal. Then only we can do addition, subtraction is equal to. Okay, and let's try it. Like velocity, final velocity L power 1 T power minus 1, initial velocity L power 1 T power minus 1. Let's do it for A into T. Okay, acceleration we know dimensional formula L power 1 T power minus 2 and time T power plus 1. So what it becomes? L power 1 T power minus 1, dimensionally equal. Let's do for this. Let's understand V square L power 1 T power minus 1 whole square, correct? Dimensional formula. So what it becomes? L power 2 T power minus 2 and you see U also same, velocity only, so you will get the same. U square also L power 2 T power minus 2, see dimensionally equal. And let's talk about A into S. A L power 1 T power minus 2 and L power 1 displacement. So L power 2 T power minus 2. See all the three dimensionally equal. So this is the meaning of this. And in this way we can find out the dimensions of unknown quantities also. Now in this few important things you need to remember, like some quantities are dimensionless quantities. Those are the first one, dimensionless, no dimensions. They don't have dimensions. Okay, they don't have dimensions. Which one? First one, constants. All the constants are dimensionless, no dimensions. Okay, and the second one, anything e to the power of anything there, e power x something, some constant there, e power k, e power whatever there in this power, it's dimensionless. K, no dimensions. And anything under log under anything, dimensionless, no dimension formula. In the same way, sine under anything there, like omega t, kx, cos kx, no dimensions, no dimension formula. Let's understand this with better some examples. Okay, let me solve from PYQs. 23rd January, shift 1. The displacement of the particle as shown in the function of time is given. Find the dimensional formula of A, B, C by D. So simple question it is given. Let's see. Now just now we have seen whenever is equal to there, addition there, subtraction there, they are dimensionally equal. So directly I can say the dimensions of D is equal to x, because x is a displacement. So dimensional formula of D is equal to dimensional formula of x of t. X of t what? It's a displacement as a function of time. Displacement dimensional formula L power 1. So D dimensional formula is L power 1. Now let's see C t square. Here you see C t square dimensionally equal to dimensional formula of L power 1. Now C dimensional formula will be L power 1 by T power 2. It becomes L power 1 T power minus 2. C over D over. Now A and B. See, A sin t, just now we have seen, is equal to dimensionally L. Under the sign, it's a dimensionless quantity. Now simply I can say dimensions of A is equal to dimensions of L. In the same way for B also, you see, B also, B cos square of t is dimensionally equal to length L power 1 and dimensionless quantity cost. Just now we have seen. B is equal to, it is L power 1 dimensions. Finally, okay, finally we want dimensions of A, B, C by D. What is dimensions of A? L power 1, B, L power 1, C, L power 1, T power minus 2 by D, L power 1. L power 1 cancel. So finally I got L power 2, T power minus 2 are the dimensions. Option number 2 is the correct answer. Thank you. Last of the particle moving in a straight line is given, and ABC are the constants. Find the dimensional formula of ABC. So we know that V is equal to C. Okay, V is equal to what is given? AT square plus BT by C plus T. See, we can equate only when dimensional formula are equal. Correct? So can I say dimensional formula of V is equal to dimensional formula of A into T square? I want dimensional formula of A. A is equal to dimensional formula V by T square. Correct? V divided by T square. Dimensionally they are equal. Velocity dimensional formula L power 1 T power 1 T square. So what it becomes? L power 1 T power minus 3. Correct? So this is the dimensional formula of A. Find the dimensions of A into B into C they were asking. Okay. A we got. Next B. If you see C, we can find out easily first. See, C plus T we did. When we can add, when dimensionally they are equal. Can I say dimensional formula of C is equal to simply dimensional formula of time? The last one, B. So you see this whole thing is equal to V. Okay, BT by this only one time you should write dimensional formula. You cannot add, right? T plus T, 2T you cannot write. Even you write 2T, 2 is constant. So I can write dimensional formula of T is equal to velocity dimensional formula. So this is also T and this is also T. Dimensionally they are cut. So dimensional formula of B you can equal to dimensional formula of velocity. Dimensional formula of velocity. What is the dimensional formula of velocity? L power 1 T power minus 1. So finally, what is the question is? Question is A into B into C dimensional formula. A into B into C. A dimensional formula L power 1 T power minus 3. C T power 1. B L power 1 T power minus 1. See, minus 1 plus 1 cancel. So L power 2 T power minus 3 is the final answer. L power 2 T power minus 3. Third option, right? Third option is the correct answer.